Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals that I offer for exams P, FM, IFM, and LTAM. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible, at least to the extent allowed by law, donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's the problem for today for exam P. The distribution of y given x is uniform on the interval from 0 to x. The marginal density of x is f sub x of x equal to 2x for x between 0 and 1 and 0 otherwise. Determine the conditional density of x given that y is equal to y, lowercase y, where positive. And here's the solution. Because the conditional density of y given x is uniform on the interval from 0 to x, and the density of x is positive only for x between 0 and 1, the joint density of x and y is positive only on the region defined by the conditions, 0 less than y less than x less than 1. So x is between 0 and 1, and y is less than x. Y is equal to x on the line, diagonal line, going through the origin and with slope of positive 1 that you see indicated in the graph below the text, so in the middle of the screen. And in this figure you also see that the area where the joint density is positive is marked with dotted lines. Where positive, in that region marked with dotted lines, the joint density equals the product of the conditional density of y given that x is equal to x times the density of x, and that's equal to 2. This means that the joint density is uniform on the triangle defined by the condition 0 less than y less than x less than 1. So we have joint density being uniform on that triangle. So remember, the conditional density of y given x is uniform on the interval from 0 to x, so its density on that interval of the conditional distribution is equal to 1 over x, 1 over the length of the interval from 0 to x. And then f sub x of x is equal to 2x. So it's 1 over x times 2x. That's why we get 2. And of course, constant density means uniform distribution, uniform on that triangle. This in turn implies that the conditional distribution of x given y is equal to y is also uniform, but x given y is equal to y has positive density only for y less than x less than 1, so that the density, which is constant on the interval from y to 1, must equal to f sub x of x equal to f sub x of x, given that y is equal to y, must be equal to 1 over y, 1 minus y, for x between y and 1, because it's uniform. Or you can just actually calculate the conditional density directly. That's f sub x of x, given that y is equal to y, which is the joint density, divided by f sub y of y. And so that's 2 over the integral from y to 1 of 2 dx. So 2 over 2 minus 2y, and that's equal to 1 over 1 minus y, either way. That's answer E again. Please remember that this is copyrighted material. The problem itself comes from the Society of Actuaries, and it belongs to the Society of Actuaries, but the solution is mine. Good luck in your studies and good luck on the test.